Welcome to lecture number 32, which is post-order traversal. Post-order traversal using one stack. So previously we discussed about how we can use two stacks to solve the post-order problem. But now let's see how we are going to solve using one stack. See, it's a lot trickier than the previous one. You need to concentrate a little bit more on this, because if you miss out a point, no, then it will be difficult. Like for me also it's the same. I've tried for around 1 hour to get this, like reading other solution and that, but finally I got it. So let me explain you how. So let's say this is 1. We'll take always the same nodes: 2, 3, 4, 5. Let's say this is 6, and that's it. We'll make it 7. Okay, and we'll make it to this to 8 and this to 9. Okay, so let's see first how we can do a post order traversal normally. So what post order means is left, right, and then your root. Okay, so let's traverse. So this is root. So first we'll go to left, we'll go to left, we'll go to left, we'll go to left, and now we'll print our 7. There is no right. We'll come back. There is no right, so we'll simply print our 6, and we'll come back. There is no right, so we'll print 4. Then we'll come here, but we have something called right, so we'll go back to 5, and we'll come back. We'll print 2, and then we'll go here. We'll go to the root node, and we have a right, so we'll go to the right. There is no left. There is a right. There is a right, so we'll print 9, 8. We come back 3, and we'll come back and we'll print 1. Okay, yeah, that's it. Like how this is how a post order traversal works. So let's see how we can write an iterative one stack solution for this. It's a lot trickier than you think. So let's make a graph again, a tree again. 1, 2, 4, this is 5, this is 3, this is 8, this is 9, this is 6, and this is 7. Okay, so our main theme should be like go towards left, 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 then right, right, right. I hope you got it. Go to right, 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 and then you print the root. That's it. It's that simple. When you're writing your algo, you should only focus on traverse towards left, 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 traverse towards right, 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 and then come to the root. Okay, so now we'll maintain a stack. Let me maintain a stack. Okay, I won't change any color. I'll place a stack. Okay, so now first I'll keep my root 1. Okay, so now I got this node, so there will be another variable which is current node, which is 1 for now. So I got 1. So after this, I'll check whether current node is null or not. It's not a null, right? So then I'll move towards left, which I discussed. Go always towards the left. Then after that you will include this 2, and your current pointer will be updated to 2. So this will be 2. Then you'll move towards your left 4. So then you'll add your 4 here into the stack, and then your current pointer will update to 4. Then you'll go to your left again. Then you'll update your current node to 6, and you'll include it in the stack 6. And now you'll go to the left again. Then you have 7, and your current node will be 7. And next you'll traverse towards the left. So this is nil. So their current node will become nil. So now what we should do in case of nil, right? What we'll do is we will pop from the stack now. Okay, this is a case we should go left, left, left when current node is not equals to nil. So let me write it down. If current node not equals to nil, then go towards left and inserting into stack. Okay, so what we need to do when the current node is nil? Okay, So else, so let me write this else. So what we should do when the current node is nil, first we'll pop out the value. So we'll pop this value out, which is 7. We'll pop this out. So we have popped it out, which is 7. Okay, let me make an array here. Print it to the result. Pop the top. Okay. After popping the top, you need to go towards where? Right. Right. That's what you need to do. See, when you try to pop your top, what you will do? You should do something right. So you should pop your top value, and then you need to see, right? So you have reached your nil. You need to pop this particular value 7. Okay. So sorry, don't include now into your array. Let me tell you when you can include. Okay. So first let's take an empty array now, empty result array. So now pop your top first. So that means you'll pop your 7. You'll get your 7. But you should not traverse 7, right? That's not your logic. Always go to your left and always go to your right. Right? So now you need to access this particular right. Okay? So that means you are accessing this right. When you access this right, so if, let's say, if this top node, you can consider top or temp node, it's your wish. Let me consider it as top node. If this particular top node is equals to nil, then obviously you should do something. Let's say if it's not equals to nil, what you'll do? You'll just, if it's not equals to nil, then you, if let's say there is some other nodes here, if it is not equals to nil, then you need to pick this. You can set this as current node, and you can simply iterate the next process, right? Again go left, left, left. That's it, right? So here you'll simply make current node equals to your temp node or top node, what we have discussed here. So top node. So let's see what we'll do in case of when top node is equals to nil. So now you just only consider if it's not on the right side, then you'll just pop it. Okay. So now you'll pop this 7 out. That means you'll include your 7 here. Okay, that's it. And now let's say, so or else what I'll do is I'll write the pseudocode for this so that you'll understand it better, because this can create a confusion for you also. So let me write here. So you'll come, you'll make your temp node or top node, it's your wish. You'll pop it, right? After popping it out, what you'll get? You'll get 7. So pop the top, right? You'll get the top node, and you'll append it into the result, which is 7. Okay. Now you will loop until for length of stack is greater than 0 and temp node is equals to your, what's your temp node is equals to stack dot top dot right. And you'll simply pop the stack, include in result, right? So if you see this node, then you'll get a basic idea like how we are iterating, because this involves multiple iterations. Like you need to go through multiple examples to get this. Okay, right? So now let me change my color again. Okay, it's again prompting me. Okay, so now let's say we got 7 and we popped it, and will this go into, is this a right node? No, right? So it doesn't go inside. Our current node will be still, what's our current node? Our current node is still nil, right? So for the next time when it comes here, it pops the top value again. So that means it pops the 6 value and it gets into here. There is no right to it. And the same when it comes to 4, then it again pops here, that is 4. And now when it comes to 2, that means you have something right, which is 5, right? So that means here you'll get something right here. That means it doesn't go into this condition. The current node will set as top node, right? So the top node will be here, this value. Here when you come to this condition, now current node is not equals to nil and left maybe nil, it's not that thing. But now here you will include your current node as 5. Okay, when you include your current node as 5, again for the next iteration you will pop this out because you have nil here. You'll pop this particular value out and you'll include here 5 and it'll go here to 2. So now when you reach here, so that means you have reached your root, right? This is 2, and 2, what you'll do is, if temp is equals to nil and if temp not equals to nil, this is a condition, right? Your current node, you'll pop it until all the values you reach is equals to not right. That is the concept of this particular thing. So now let's consider when you are at 5, what happens. When you are at 5 and you reach a nil pointer, then you'll go here, and what happens, you need to pop until the right node is equals to temp node, right? So your temp node will go to this, that means you'll pop this, and also you'll include it into the array, and next you'll pop for the sep 1. But while popping the 1, you need to say that it contains its right, so that means you will initialize to the right and then you'll initialize to your top node, and the same repeats again to the right side, I mean to this right, and then we'll pop the values and simply we can mark them as 8, 3, 1. So this forms a solution. Yeah, I know it sounds a little bit confusing, like it's on the trickier side, like you may not get on the one go, but while practicing it you'll get it. If you have any doubts, please make sure to comment, I'll be replying there. So let's jump into our coding session. So let's see how we can write code for this particular Postorder Traversal using one stack. So as we discussed, we already discussed the pseudo algorithm, so it will be same like that. Okay, so let's see. First we'll initialize a stack which is of store node pointer, and current node will point to our root node. We loop until length of stack or current node not equals to nil, and we'll take if current node not equals to nil, then what we discussed, we need to traverse to the left, right. So we'll append to the stack and we'll move the current node pointer to the left. What if current node is nil? So that means first we'll pop the temp node, that means the node which is present in the stack, and we'll watch it right, whether it has some right or not. Let's say if it has some right, then we'll simply mark current node to temp node. What if it doesn't have some right? So that means we need to pop the values until you reach the toppest node, right? I hope you got it. So what that means is temp node equals to stack of length of, that means you need to remove the entire right nodes, like the right track. You need to remove right node 1, right, until you reach the top node which is a left of another node. That's it, right? And until then you need to loop. So let's see. Temp node, first you will pop one value and you will do this is popping out the last value, and you're taking that stack because you do not have a node with you because temp node is nil. And now you will track greater than 0 and temp node equals to stack dot length, that is it is right of some particular node. Until then you keep on picking up the top node, you will print that and you will pop the value. That's it, and you repeat the same. Hope you got the problem. Yeah, it's a little bit on a trickier side, like it's not that simple when you compare with post order with 2 stacks or like in order and pre-order traversals using iterative approach. Spend some time with it so you will get it. Okay, got any doubts or questions, drop them in the comments and I'll do my best to answer them. Don't forget to like the video and subscribe to the channel if you enjoyed it. Thanks for watching and I'll see you in the next lecture. Until then, bye bye.